Yeah, there. Today we're going to solve another LeetCode problem named largest rectangle in histogram. Hard level, and it goes like this. Given an array of integers heights representing the histogram's barred height, where the width of each bar is 1, return the area of the largest rectangle in the histogram. Well, there are some examples over here which show exactly how this max area could look like, and also some constraints which show that, well, heights array is never going to be empty, and also all heights values are going to be positive. Okay, so let's start to work on our code. As you can understand, we are going to have some kind of max area variable. Let's put some negative value over there. We will try to override it and return it as a result. So to find an area of any rectangle, you do need its height and width. And in this particular case, to find the width, you do need to know its start index and end index on the histogram. So what I would suggest is to iterate through all of the heights, and whenever we encounter some height which represents an absolutely new rectangle, we should memorize its index and use it as a start index of the rectangle. And whenever we encounter some height which value is less than the value we've memorized for, then we should use the new index as an end index of that rectangle. Well, we could calculate the area of this rectangle and drop all the related information about this rectangle from the memory or from cache. Name it as you want. So let's create this cache, something like rects. It's going to be an array of tuples. Each tuple is going to have information about the height of the rectangle and the start index. Let's name it from index. Initially, it's going to be empty. And let's start iterating through our heights using the for loop. So for indexes from 0 to heights count, we are going to get the height from the heights as a first line of this iteration. And now we need to do two actions. First, we need to check on existing rects, right? And another thing, we should append a new tuple to rects, but only if needed. So let's start with the second action. The thing is that if we are going to append new information to the tuple whenever we encounter some height which represents an absolutely new rectangle, and at the same time, if we are going to drop information about the rects which height is greater than the current one a few lines before, it means that the rects array is going to be naturally sorted in the ascending order by the height of the tuples, which means that if we would like to append a new tuple to the rects, we don't need to check all the elements in the rects itself, and we should just check the last element. So let's check if rects last height is not equal to our current height. And if it is, if it's so, then we're going to execute append with the new tuple on the rects. So here we're going to append the new height, and also we need to provide the start index of this rectangle. At the moment, let's use just index, but it is a little bit more complicated. We'll get to that later. Now let's get back to the checking on the existing rectangles. As the rects are sorted by height naturally, if we would like to handle all the rects which height is greater than our current height, then we should do it in the reverse order from the end to the start. So let's create some variable, something like last rec index, which initially is going to be equal to the rects count -1. And while this index is greater or equal to 0, and while the rectangle, which is represented by this index, has a height which is greater than the current one, then we are going to handle it and decrease the index by 1 to proceed to the next step. So how we're going to handle it? First of all, we're going to calculate the area of this rectangle. For that, we are going to use the height of the rectangle and multiply it by width. Width in this case is going to be calculated as a current index minus the start index of this rectangle. And finally, if the area is greater than our current max area, then we are going to just replace it with the new value. Nice. All right, let's get back to this index which we were using to append the new tuple to the rects. So the thing is that over here we are going through all of the rectangles which height is greater than the height of the new rect. And it means that they partially form this rect as well, even if the height itself wasn't encountered yet in the array. So the index should be shifted a little bit to the start. So let's use some other variable, something like current from, which initially going to contain the index. And when we are going to iterate through all these rectangles of the greater height, we could replace the current from with the from variable from these tuples. So in the end, the current from is going to contain the start index of the rectangle, which is the most closest to the start. All right, so we handled the calculation of the area for those rectangles. Now let's drop them from our cache. And for that, let's first calculate the rects to remove value. So for that, we are going to use the last index of the rects and reduce it by the current state of the last rect index. And if the rects to remove value is greater than 0, then we could execute rects remove last and provide this number as an argument. Nice. So we went through all of these heights in this loop. And well, the thing is that we do calculate the area and replace the max area with the new value only when we encounter some height which value is less than the value of the heights in the rects, right? And for example, if we have a histogram of monotonically growing bars, this code is not going to be executed ever, right? Basically, we need to handle all the leftovers in our rects array and calculate the area for them. So let's use another for loop. So for rect in rect, let's get the area first for this rect. So we are going to use its height and multiply by the width. As for the end index, we are going to use the heights count, right? And as its start index, we are going to use the start index of the rect itself. And again, if area is greater than the max area, we are going to replace this value. And that's it. Let's check for any compilation issues. Something over here. Oh, it's not value, it's from. Yep. Nice. Finally, let's submit this solution and check its performance. All right. So as you see, it was executed in 0 milliseconds technically on all of the test cases and beats 100% of other submissions, which means that the execution time basically stands somewhere on the edge of the threshold. And that's it for today. I hope you enjoyed this session. If you'd like to see me solving any other LeetCode problems, then put your request to the comment section. See you next time. Cheers.